Now, in this lecture, we'll start learning about statistics and what statistics play in terms of probability and statistics as a whole. I will first introduce the topic, what is descriptive statistics, and we'll learn about descriptive statistics and the summary and central tendency. What do you mean by summary and what do you mean by central tendency? Then we talk about group data distributions, measures of dispersion. Perhaps we may not be able to discuss the whole today. Perhaps we'll be doing 1 and 2 today, depending on our time availability. And I'll move to introduction first. The learning outcomes for this lecture series include you'll be able to identify and describe the key concepts of descriptive statistics. Keep this in mind. We'll learn about descriptive statistics, and after completing this lecture, you should be able to tell what is descriptive statistics and what sort of key concepts are there, what do you need to learn, and you should be able to describe the usefulness of these concepts. The second learning outcome would be calculating descriptive statistics. Now, carefully observe that there is a S in this. There is a difference between statistic and statistics. We'll be learning how to calculate descriptive statistics for deriving useful numerical summaries. The third learning outcome is analyzing and applying measures of dispersion to evaluate the spread of data and understand the variability within business data sets. The fourth one is interpreting the coefficients of variation to compare relative variability and applying concepts of descriptive statistics to summarize data sets in business context. Because we'll be covering the entirety of descriptive statistics in this lecture series, you will be able to start from the concepts all the way to the application. Let's dive in. I will start with frequency charts and histograms. I'm sure you are already familiar with this one with our probability distribution part of the previous lectures. We'll then talk about measure of central tendency and dispersion, then elementary probability theory. We have talked about binomial, Poisson, and normal distributions, time series, and all these things. I'm not going to talk about time series and moving averages here, but we'll try to come up with wherever necessary to the points that are required. Let's go in. Now, most of you might have an idea about statistics from your maybe school days, maybe from your other classes, like if you are following maybe SIMA or some external courses, you may have an idea of statistics. But to bring everyone to the same page, can we have this chat? What is statistics? Think of statistics as a tool set that helps us to make smart choices. It is all about gathering numbers, sorting them, looking at them in different ways, and using them to make informed decisions. As you can see, the entirety of that the paragraph or a sentence include several key things. It's about smart choices, it's about gathering numbers, data, and looking at them in different ways and using them to make informed decisions. Now, statistics, as I said earlier, is a combination of different statistics. You can think of it as statistics because it's always about a combination of different statistics, right? So why learn statistics? Knowing statistics helps us to make sense of information you see and hear every day. Now there's a little video here. You can watch it because you have the lecture slides with you. This is available on the Moodle. Just click on the short video link and then watch it. I will not take time today to watch that because we are doing the online session. it talks about how data can be used to come up with decisions and visualizations and all. Earlier, statistics was mostly about gathering and jotting down numbers. If you look at previous days, the history of statistics, what people did was they would take a piece of paper and then just collect numbers. Now, in the early days, when people did that, they would just take a piece of paper and then write down numbers. So they started visualizing things, they started drawing charts, and some of them were mainly into quantitative sides of it. They started developing different summaries and so on and so forth. After fairly, 50 years or so, maybe 100 years, now it's not just about collecting data. Now we are trying to understand it and use it. Today, whether you are in a company, government, or just making personal choices, it can be your finances, it can be your everyday life choices. Some knowledge of statistics is really helpful. Now, I hope you have an idea about what is statistics and some inquisitive understanding of the nature of statistics, some curiosity to learn. There are two types of statistics. One is called descriptive statistics, the other one is called inferential statistics. In the case of descriptive statistics, what we do is mainly constrained to the sample. In the inferential statistics, the population is in concern. I'm sure you remember the population and the sample from our probability lectures. Descriptive statistics and inferential statistics deal with those two in terms of statistics. Let's look at what is descriptive statistics first. Descriptive statistics focuses on providing comprehensive summary highlight. So you have a summary highlighting the salient features and characteristics of the data set in question. It encompasses the techniques and methods related to data collection, organization, presentation, and analysis. So it's a collection of many things. You start with data collection part, you have the organization part and presentation and analysis. You look at the perspective. If you remember the probability lectures, you have the entire population like this. You are taking a sample out of the population. And this is where you do the descriptive statistics. Now, let's look at the difference between descriptive statistics and inferential statistics. Where descriptive statistics is mainly concerned about the sample, inferential statistics is concerned with drawing meaningful conclusions about a larger population. For example, if you look at the University of Moratuwa, you have University of Moratuwa. And inside University of Moratuwa, you have different faculties. Let's say engineering faculty is there. Then you have the medical faculty, Archi. Then you have business faculty, so on and so forth. If you want to understand about the student perception or the issues of students in University of Moratuwa, you need to get meaningful conclusions from different sectors, right? You can't just go and say, all right, I am going to sample only the medical students and then say this is University of Moratuwa students' perception. I'm going to do only sample engineering students and tell this is the University of Moratuwa students' perception. You need to get rid of that idea, you have to go and do sampling from all the faculties. It should be a representative sample. So how to do it? That is what we are going to learn in statistics in this part of the course, and also how to infer using this sample, because you can't go and ask every student in the University of Moratuwa and do the analysis, because it will be time consuming. First, the easiest thing to understand is, even though you can do it, it will be extremely time consuming. And by the time you do the analysis and come up with your results, the requirements will be expired, because we don't know how quickly you can come up with a solution, right? So if for a certain question, your answer would be late. That's one, you can't come up with rapid decisions. And of course, the the best answer is you can't do it for the entire population, because if you look at University of Moratuwa, yes, you can look at the population as a finite population which you can mingle with. But if you take a look at Sri Lanka or the world in general, it's a very large population and requires tremendous time and money and effort to do such a survey. So that's the reason why we learn descriptive statistics and inferential statistics, so that you take a sample, do some analysis, and infer, or in the terms that are used here, draw meaningful conclusions about a larger population. These conclusions are derived based on the analysis of sample extracted from that population. This was pretty easy to understand in terms of COVID. If you look at COVID, what happened with COVID, it was spreading all around the world. And if you want to identify whether a certain area is affected, just by taking a sample of the population, you can look at whether the numbers and also whether it's spreading. That's actually part of pandemics and epidemic analysis. In essence, inferential statistics allows us to make educated assumptions about a broader group by examining a representative subset of that group. I hope you can understand the difference between descriptive statistics. Descriptive statistics mainly look at data collection, organization, presentation, analysis for a given data set, takes the taken sample. Inferential statistics use that sample to talk about the population. I have given a little demo here. Imagine you look at the population of chocolates. So chocolates all around the world, or if you interested in a particular brand, let's say brand one. So you have brand one, a population of chocolates. In this population, you can take a sample and do the testing to check whether a certain quality is present. It can be the flavor, it can be the possibility of storing it, or it can be the price. Doesn't matter. If you want to study it, there is only a probability to pick a sample from that population. If you have millions of chocolates, there is only a probability to pick a certain sample, right? You can pick your sample from here, you can pick your sample from there, or your sample can come from anywhere. So there is only a probability, a certain probability, that a set of chocolates will be chosen. That is your sample. When we talk about the sample, we tell it's descriptive statistics. We'll talk about what are the descriptive statistics in terms of a given sample, but you only have the sample to deal with when it comes to descriptive statistics. You come up with different values, different statistics using your descriptive methods, and then you use those to infer about the population. If you start with something, you need to have some idea what you are going to do, right? Imagine you are testing the flavor, chocolate flavor. You need to tell, like, you need to state some hypothesis. And from this hypothesis, you have some idea whether to test something or not. You take it out, and there's a probability to take a certain sample out. You take some analysis, you do it. And when you infer, you are inferring about this hypothesis, whether the flavor is there, whether the price is there, whether the quality is there. It doesn't matter what, but you need to have a certain hypothesis to test. So that's why we infer. We infer from the descriptive statistics, the statistics that we take from here. That is the circle of descriptive statistics and inferential statistics. It goes like that. I think we had a similar discussion in the very first lecture. I'm not sure because I'm a bit confused about the places I do this one. Anyway, let's do this again if you have done it. So there's a restaurant that wants to evaluate the quality of their food. They randomly select 20 dishes from their menu and taste them to measure factors like taste, presentation, and portion size. So can you tell me what is the population here and the sample in this situation? Send me a chat message or you can speak out. So what is the population and what is the sample? Population, menu, sample, 20 dishes. Population, menu, okay, sample 20, right, good. Population is the menu, sample is the 20 dishes. All I don't know. Right, great. I think we might have done this exercise previously as well. I forgot. The population is all dishes available in the restaurant's menu, while the sample is the 20 dishes that were randomly selected for evaluation. By analyzing the data collected from the sample, the restaurant can infer the overall quality of their menu and make necessary adjustments to improve the dining experience for their customers. That's the beauty of using a sample to infer about the population. Now, can this vary? Yes, because every time you take 20 dishes randomly from the available, you are doing actually sampling. And when you do sampling, there is only a probability of taking those 20 dishes. If you remember your lessons about NCR and NPR, particularly NCR, if you have 100 plates, 100 different dishes are already available, pick 20 out of this belongs to 100C20. And you can see the number of possibilities you can think about. If you have such number of possibilities, just taking 20 and evaluating the menu from those 20 need to have a certain logical flow, a certain mathematically acceptable format. That is what inferential statistics is about. You can think of all possibilities, multiple ways in which you can select. Of course, statistics in general is about not about the correct answer or the perfect answer. It's always about the perfect estimate. There is a difference between the estimation or the estimate and the exact answer. The beauty of statistics and probability lies in this estimate. The beauty of data science lies in the estimate part. It's not the actual correct exact answer. It's not the deterministic answer. It's just an estimate. And estimates can always vary. It is only having a certain probability of being accepted or happening. If you tell tomorrow it's gonna rain, or if you tell today afternoon it's gonna rain, it's just an estimate or some forecast. There is a chance of happening, and also there's a chance of not happening. Only thing that we do is try to make sure that how probable that is. That is inferential statistics. Let's try to start with individuals, variables, and observations. Any set of data, recorded observations, contain information about some groups of individuals. The information is organized by variables. You have the key variable, that is the ID, like your index number. Then you have some qualitative measure like the type, also place, item, and also numerical values like registered price or discounted price, etc. Individuals are the objects of interest described by a set of data, the row of the above table. So if you take a look at one row like this, it contains an instant and extract of the available points, available data set. So if you take a look at this particular row, it talks about the ID1, which is an Italian type place, most place, it's an item of pizza, and you have regular price and discounted price, so and so forth. You can look at the missing values, you can look at the changes in values, and also the example as a row. Then you have variables, characteristics of individual, different values for different individuals. Column of the table. If you look at like this, it's the place, the variation of places, something we record or measure from the population. Now, individuals, variables, and observations, we don't necessarily talk about them as such, but it's good to know what they are. A variable represents some characteristic, amount, or quality that we can observe or measure. Like in the previous case, whether it's a pizza, whether it's the price, the quality that we can measure. Think of it as a placeholder for information we are interested in. Variables come in various flavors depending on how they can be observed. You have categorical variables. Those are actually called qualitative because it talks about quality. It's not a measurement, it's a quality. It can be about the gender, whether it's a girl or a boy, or it can be about ethnicity or let's say citizenship. Can be an Australian, Sri Lankan, Indian. It's about a quality, some class. Those are qualitative variables. That's one type of variables that we find. The other type is numerical. In terms of numerical, we have a measure, quantitative. If you think about your height, you have a height. This is measurable. It's a quantitative variable. It's a numerical variable. And if you think about the measurements of time, if you are waiting for a bus to arrive somewhere and you have a clock to measure it, then that's actually the time between those two locations. That's also quantitative. It's a numerical measure. Anything that can be measured belongs to numerical. But of course, anything that you measure can be converted to categorical as well. For example, you can always give, if you have a certain height, let's say that you are going for an interview, Maybe it can be for air hostess, or it can be for the military. In both cases, they are measuring the height. And there is a certain height level that they say is not applicable. So anything that is above that height level is accepted. So if you are lesser than that height, they say disqualified. If you are higher than that particular measuring level, then you are qualified. So what you have done is you have used a quantitative variable and converted that into qualitative variables like qualified and disqualified, two different classes. You can use numerical values and convert that into categorical values as well. You can do vice versa, but converting categorical to numerical is something of a, it requires some understanding of the data and what you are really looking at. The categorical variables, they belong to another three types: nominal, ordinal, dichotomous, or binary. This is like the air hostess and military case where you have two categories, yes or no, qualified or disqualified. Dichotomous, if you look at the dictionary, dichotomy means two distinct classes. You have some divisions and then you have one class and the other class. It's very easy to understand in terms of binary, 0 or 1, yes or no. In the case of nominal, it's a name. It can be any name, the faculty of business, faculty of engineering, some name that dictates the class. And ordinal means some sort of a rating system. It can be mid, high, low. It can be some in between value like good, bad, good. If you look at starting from good, good, then you have better and best sort of. So it's actually some sort of a rating system, and that's a categorical interpretation. We call this ordinal. Again, to sum up, you have nominal variables, ordinal variables, and dichotomous or binary variables like gender, yes or no, qualified, disqualified, those kind of two distinct categories. And they all belong to the categorical variable class. In terms of numerical quantitative variables, you have interval and ratio. Interval, in the sense, it belongs to continuous scale or equal gaps. No true zero. Like temperature in Celsius, the height, the length, and so on and so forth. Ratio, like interval, but with a true zero, height or weight. Here, again, you can see interval can be height or weight as well, and ratio can be height or weight as well. Because if you are giving an interval between sort of a scale, in terms of equal gaps, you can take height as an interval measure. But if you are giving a value, then you can go for a ratio measure as well. It depends on how you take it, interval or ratio. The four scales of measurements, you have nominal variables, ordinal, interval, and ratio. These are different types of measurements. Nominal variables include the names, right? Just for the sake of understanding it, you can say names. Nominal variables include names. So you can have two or more categories. They do not have an intrinsic order, because if you say Australia, Sri Lanka, India, in terms of names like nominal variables, unless you have a particular order insisted on that, on those names, you don't have an intrinsic order, just names. But if you have an order, then it becomes ordinal variables. Have two or more categories. Categories can be ordered or ranked. Like in the case of let's say, some tournament, can be cricket tournament or a football tournament or any game. If those countries become ranked based on their performance, then it is ordinal. Magnitude between consecutive values is not equal. In the case of interval variable measured or on a continuous scale, do not have an absolute zero, like absolute zero in the sense like you talk about zeroth position, right? Exact zero. But in reality, you can't really talk about zero because if it is a measurement, you always have non-negative values, right? It will always be greater than zero. Do not have absolute zeros. Differences between consecutive values are equal. Ratios are not defined. You can't define a ratio in case of interval variables. It can be time interval, easy to understand, length interval. If it is temperature measurement, you have a particular interval. Ratio variable, interval variable with an absolute zero. If you don't have a length to measure, that's a zero. So interval variables with an absolute zero becomes a ratio variable. Ratios between two levels are defined, some high or low. If you take a look at some value a divided by b, that's a ratio. Okay, now we'll look at the takeaways from what we learned. Variables are crucial in research and data analysis. So we learned about two types of variables. One is qualitative and one is quantitative. And they are crucial in research and data analysis. Different types of variables offer different insights. If you look at qualitative classes like country or ordinal or combination of them, they offer different insight. If you take quantitative and look at them from that aspect, they offer a different insight. Choosing the right variable type ensures accurate and meaningful results. Depends on how you want to describe your sample. Then you choose the correct variable type and store your data likewise. If you need to actually analyze the height distribution, you record the numbers, the height in centimeters, and then you keep on recording. If you need to collect the weight measurements, you collect weight in kilogram and then record the measurement. Time, minutes, hours, depending on your requirement, you choose the right variable type and then you collect the measurements. Now, let's move to the takeaways. This is a mind map of what you have. You have qualitative variables and they become nominal, ordinal, binary. Quantitative, they are discrete and continuous. Very easy to remember. Just as we move on, you can actually think of the correct variable type depending on your requirement. Now let's move into descriptive statistics, summary, and central tendency. Summary statistics. Now, to get a bit of an understanding of what we are dealing with, can you tell me what is the meaning of a summary in your opinion? Send me a chat message or you can speak out. What is, in your opinion, is a summary of something? It's not about statistics. I'm asking a general question. What is a summary in your opinion? Okay, one answer is important points of all. Any other? Basic of content, right? Any other? Telling something briefly, the gist of something, very good. Final conclusion of the content, okay, good. Any other? Simplifying of something, good. Any other? Brief understanding about something, right? So, main and basic meaning of something, good. Any other? Brief statement of main points, good. Right. All the answers are very good. A summary is actually, if you look at a summary, you can look at it in terms of different perspectives. Let's look at, if you are, let's say you look at a movie, okay? Let's talk about a movie, right? Now, have you all watched Harry Potter? If you have watched, can you just put an emoji, thumbs up? Have you watched Harry Potter? Right, everyone has watched. Okay, good. Now, in Harry Potter, if you look at a summary from a movie point of view, you would say there is this boy, and then the boy, I'm not spoiling it for anyone who has not watched. So this boy has these things, and then there is a particular school, and then and so on and so forth. That's a summary of the story. But if someone asks you, summarize Harry Potter in terms of the the magic used in it. So you don't go and talk about the life story of Harry Potter, you'll talk about the magic. If someone asks you summarize what is Hogwarts, then you look at Hogwarts and then summarize it. If someone asks you what is the Slytherin house, can you summarize Slytherin house for me? Then you would go and summarize Slytherin. Then, and also you can look at other houses as well, Gryffindor or Hufflepuff, depending on your requirement. And that's about the level of summary that you need. If some of your friends ask you, tell me what is the summary of the lecture, what happened there? You can tell different stories. Someone would tell the lecturer came and these were the things happened, so and so forth. And someone might say, look, I didn't listen to the lecture, but these were the things we did during the lecture. That person slept. That person was in the Facebook for all the time. He was watching this and that. So that's a summary, but it's a summary about the same lecture, but in different point of views, right? Now, as I said, all of your answers were correct. There is no right or wrong answer. Summary is a gist of something, and the way that you look at the summary depends on the perspective. In descriptive statistics, summary statistics are used to summarize a set of observations, and this summary can vary. It is a summary of, it can be a summary, as I said, about, if you look at Harry Potter, it can be a summary about the movie, it can be a summary about the magic, it can be a summary about the houses. It depends on the perspective that you look at the data. It's not a final holistic summary and the final summary of everything, because you can't give the final summary for anything. It depends on the perspective. Summary is depending on the perspective. Communicate information simply and effectively. If I ask you, how did you enjoy your university life? I can ask your answer, I can ask the answer from different perspective. What is it about the life as a young boy or a girl? What is your expectation about your academics? What is your summary about the food and the vibes at University of Morocco? It depends on how you look at the problem. Communicate information simply and effectively. Statisticians describe observation in terms of measure of location, that's central tendency, measure of dispersion, that's spread. If I may draw some picture of this one, central tendency is like this. Imagine that you have your data points spreaded all around the space, and let me use a different color. So central tendency is like where the data set is more or less centered around. The point of central importance. They can be spread in space or in terms of different variables, but the location, the central tendency, that's where the data points are mainly located. Then the spread. So the spread can be if I may use green color, the spread can be this spread, that spread. And also the distribution shape. If you look at the data points from a distribution point of view, you can draw a histogram, a frequency chart like this. And in terms of the distribution, it may go like this, or you can draw it like this, two bumps, right? Depends on how you do it. And measure of skewness, distribution shape, how you distribute your data in terms of a distribution, and measure of kurtosis, flatness or peakness, which means the height of this distribution. Now, all these measures are actually summaries of the data, and depending on the requirement, as I said about the Harry Potter movie, the central tendency, the spread and distribution, and all these things will come in handy depending on what you are going to describe, what you really want to describe in the sample. The key measures of central tendency belong to mean, median, mode. So I'm sure you have heard of these things. I don't need to explain what mean is, but we'll quickly go through. Mean is simply the average of things, and the median is the central point of where the data is spreaded. And then you have mode, the frequency of appearance. The following are some important types. You have, if you take a look at mean, you have simple arithmetic mean, weighted arithmetic mean, combined or composite arithmetic mean, geometric mean, harmonic mean. If you take a look at median, median is there, and then you can go for quartiles, deciles, percentiles. Mode, of course, it's frequency dependent. Because of that, you mainly talk about mode. Of course, you can have more measures as you require. Now, in general, central tendency is like that summary. If you look at, if I ask you in simple terms, who is University of Moratuwa Faculty of Business student, you tell me something about that person. One statement, he or she comes from this particular subject stream and a good performer, some sentence about that. That's actually a central tendency, a description about, a summary about that particular set of people. So that's actually a mean, can be a mean. If I ask you something, actually you have an idea about mean, median, and mode, about the central tendency inherently, but you don't have an idea about them explicitly. So mean is simply some single measure of an entire data set, some single measure about an entire data set. Let's look at simple arithmetic mean. The simple arithmetic mean of a set of observations is equal to the sum of the observations divided by the number of observations in the set, which is a very simple concept. If you have, for example, ID here and the height here, height in centimeters, take a look at the units. Units are important. Centimeters, meters, or kilometers. The units are important because the distribution, the mean, and everything will be described based on the units if you are looking at numerical measures. If you take ID 1, 2, 3, and if you have height of 150 centimeters, 145 centimeters, 158 centimeters, then the simple arithmetic mean means you just simply add them, 150, 145, 158, and then divide by the number of occurrences, that is n. So divide by 3, then you get an answer. Now, simply you just add them together and do the math. 150 will be 300, 300 minus 5, that is 295, 295 plus 5, that is 300, 300, 153, that's going to be 453. Divide by 3, So you have 1,551 centimeters as the mean. Now, if you take a look at this, right, the simple idea of simple arithmetic mean is, if I ask you, out of these three individuals, what is the mean height? You would say 151 centimeters. And on the scale, if you want to draw them, you just take like this, and this is 1, 2, 3, and then you can have a measure of, let's say, 150 to make it simple. Draw a line like 150, let's say 151 to be equal. So this is the mean. If you draw this, you can see the first ID 150 is pretty close to that point. 145 maybe 5 down, and 158 8 up, somewhere around that. Now, if you measure the distances from the mean, they have different distances, but in general, if I ask you what is the average height of these three individuals, you would say 151 centimeters. So that's a single measure of all these three people. Now you can extend this into large groups depending on what you really want, and it doesn't matter how many people are there. You can go and tell a single measure, and that is central tendency. That's a single measure of it. So if you look at the population, the mean of population is denoted by mu. This is called mu. You write it like this. That's the mean of the population. The beauty of this one is you can not measure the mean of population. You can measure it, yes, but it's a very tedious task. You have to look at everyone in the population to get this mean. Because of that, it's actually a parameter. We'll learn about parameter when we learn about inferential statistics. So whenever I use mu, that indicates it's the population mean. Please keep a note of it. Whenever I say mu, that's the population. That's a fixed value for population. That's a parameter. But whenever I say x bar or capital X bar, that is about the sample. So X bar, simple X bar, is used when the sample observations are known. Sample observations are known. These things might be a bit confusing at the moment. What is sample observations are known and what is sample observations are unknown? We'll talk about them. We have quite an extensive lecture on this sample distribution, sampling theory. We'll talk about it, but for the time being, just have an idea that simple X bar indicates when the sample observations are known. Whenever I give this thing, these observations, so this is a simple X bar. Capital X bar is a concept. It's like you can draw multiple samples out of the same population, and for each of these samples you can have an X bar. So capital X bar is used when we talk about those X bars, all the simple X bars, right? We'll talk about it. So just an idea, capital X bar is used when the sample observations are unknown. Given the population values, all these things, mu is defined in terms of all the values in the population, which we cannot really measure. We can only measure about a sample. You can, but that's a tedious task. Now let's go to the simple arithmetic mean in terms of values unknown. You have capital X bar when the unknown values are there. So the thing that we have been using since our childhood, since our grade 8, I think, this simple X bar, you add them up, divide by the total number because the values are known. That's about simple arithmetic mean. Then we have weighted arithmetic mean. Weighted arithmetic mean is something that you associate a particular observation with a weight. You have an observation x1, x2, x1, x3, x all the way up to xn, like the height, but now you associate that with a weight. It can be anything. It can be the number, it can be the number of students, or it can be a weight that you come up with. Now there's a little example here. A student's final marks in mathematics, English, statistics, and computer are these. If the respective credits, now you have your GPA, similar to that, credits received for these courses are 2, 1, 3, and 4. Determine an appropriate average mark. Can you do that for me and give me the answer? Look at the equation and then get the weighted average or the weighted mean, weighted arithmetic mean, and tell me what is the answer. So I guess 86.5 should be correct. It is the answer that everyone, like most of you have got. So that's correct. Now let's look at combined composite arithmetic mean. Simple arithmetic means of two or more related groups can be combined into a composite mean as follows. Now, idea here is that a set of simple arithmetic means of k related groups. Previously, it was about credit, some weights that you assign with a certain number. It can be a class or something. But here we deal with the classes. For example, you can look at this question. There are 3 branches of a company employing 100, 20, and 80 persons respectively. Let's look at the company. So there is this company, and it has 3 branches. I would say branch 1, branch 2, and branch 3. The first one contains 100, the second one 20, and then 80. If the arithmetic means of the monthly salaries paid by the 3 companies or 3 branches, 50,000. So this is 50,000. And then you have 60,000, I would say 60K, and then 80K. Say K. All right. Now, 50K, 60K, and 80K. These are the average means of the monthly salaries. We don't look at the employees per se, one by one, but we have some idea about the central tendency, which is if you have values distributed, we know the central tendency of those branches, different branches. Now, the idea is find the arithmetic mean of the salaries of all the employees of the three branches. That's one company, of the company. That's what it says. All right. So how do we do it? Because we have means, X bars are there. We don't know about each and every salary inside the branch, but we know the mean of it. So you can get the composite mean or the combined arithmetic mean by simply multiplying it with a number. Because in general, what do we have? If you have X bar defined in terms of sigma xi divided by n, simply getting this n out, nx bar would give you sigma xi. That's the combination of all the things. So in general, what we do is to get the combined mean, again, we need to add everything and divide by the number. So instead of that, what we do is multiply by the number and divide by the total number. So the answer to this one is the composite mean of the company is going to be 100 times 50K plus 20 times 60K plus 80 times 80K divide by the number 100, 20, 200. This is the answer. I hope that is clear. Now let's go to the next one about geometric mean. What is geometric mean? Geometric mean is a type of average usually used for growth rates like population growth or interest rates. It's simply the multiplication and divide. It's a square root, or not the square root per se, but the root mean of the multiplication. The geometric mean can only be used with positive numbers because you can't define negative. For certain cases, you can't define negative roots. Right, so set of k observations. So this particular sign pi, maybe you are not familiar with this particular notation. It's actually multiplication. So what it says is, if you have, let's say, again, I will go back to my example ID, and let's say instead of heights, let's take some, I would say, let's say interest rate or something. Now 1, 2, 3 is there, and let's say this is 0.2, 0.3, and 0.1, right? So the geometric mean means you simply multiply them. So sigma I equals 1 to k xi means you just multiply 0.2 times 0.3 times 0.1. Remember, this multiplication is coming from this pi notation. Previously, if you use sigma, it indicates a plus sign, addition. This is multiplication. And then, of course, if you add them, you can divide. But if you multiply them, you need to get the square root or the root of it. So you have 1, 2, 3. The root of this is going to be the 1/3 power of this. So you take 1/3 power of this. You can do some manipulations, like this would be 2 times 3, that is 6, right? And you have 3 decimal points, so that's going to be 0.006, 0.006, 1/3 of this. And that will be your G. Try to do this question. The economic growth rate of a country for the last 3 years is this. What is the overall growth rate? Can you do this? I got 2 answers. One is 4 and one is 4%. The correct answer is actually 4%. Make sure that you put that exact unit, percentage sign is important, or you just put 0.04. Make sure that you put the unit sign, otherwise the answer is wrong. Okay, just 4 is wrong. It should be 4%. The answer should be either 0.04 or 4%. Without the percentage sign, the answer is wrong. Keep a note of it. Whenever you give answers to statistics questions or this paper in general, make sure that you put your units correctly. If you haven't put the unit, the answer is wrong. Then you have geometric mean and alternative version, which is about the observations where you add them up, and overall growth rate, not really important. You can just skip it. Then you have something called harmonic mean. The harmonic mean is a very specific type of average. It is generally used when dealing with averages of units, like speed. When you have some unit like per meter, per second, per kilometer, sort of. Let x1, x be a set of k observations, then k divided by the sigma of inverse of these things is equal to the harmonic mean. The speeds of 3 deliveries in kilometers per hour of a fast bowler are 60, 90, 100. What is the average speed? Because if you try to get the average speed of of this, just adding this would be not correct. So you have 3 deliveries divided by 1 over other speeds, like you have 60 plus 1 over 90. Is geometric mean equation same for negative values? No. Geometric mean can only be used with positive numbers. You can use the alternative version here. for negative numbers. That is geometric mean. This you use it instead of xi sigma. This you just use multiplication with +1. I hope that's clear. For negative values, you don't use this equation. For negative values, you use this equation. So you have negative 2%. The equation becomes xi plus 1 minus 1. So you multiply the thing with +1 sign. Alternative version used with negative numbers. Right. Where was I? Yeah, for this one, harmonic mean 90 plus 1 over 100. The answer is going to be, just make it take your calculator, just simply you can do 3 divided by 1 over 60 plus 1 over 90 plus 1 over 100, and that's 79.411 kilometers per hour. Make sure that you put the unit. Great. Let's move on. The relationship among the simple arithmetic, geometric, and harmonic means is very interesting. For a set of positive observations with at least 2 different values, the harmonic mean is the smallest, and the simple arithmetic mean is the greatest. And you have geometric mean at the center. Calculate the simple arithmetic mean, geometric mean, and harmonic mean of 2, 4, 4, and 8. So you can do it. Just do it and see. The idea is the harmonic mean. Now, these can be coming in MCQ questions, like you have few values and maybe someone large values, and then you can get the options, like what can be the harmonic mean and the geometric mean and the arithmetic mean. Then you can sort of get an idea. Okay, always the harmonic mean should be the lowest and the arithmetic mean should be the highest. So the geometric mean should be always at the center. In that way, you need to have some idea. Okay, so just keep that in mind. Then let's go to mode. Mode is defined as the value of the variable which occurs most frequently in a distribution. Most frequently in a distribution. If there is only one mode in the series, it's called unimodal. If there are 2 modes, it's called bimodal. If there are 3 modes, it's called trimodal. There are more than that, it's called multimodal distribution. Unimodal, bimodal, trimodal, multimodal. 12 students in a class have the following shoe sizes. What is the mode? Can somebody tell me what is the mode? Got 8 as an answer. Okay, 8 is the answer. You have 8, 8, 8, 8, 8. Right, so you have 5 8s, and that's going to be the mode. Most frequently. Now, if you have another number that has 5 occurrences, it becomes bimodal. This is a unimodal distribution. If it has more than that, that's becoming trimodal or multimodal, depending on the way. Then you have quartiles. quartiles are the values of the variables, and then you order as ascending order, which divide the distribution into 4 equal parts, are known as quartiles. Each portion contains 25% of the total number of items. It's actually a number of items thing. When you talk about quartiles, it's always about the number, 25% of the total number. It doesn't have to do with anything with the values in the distribution. Remember that. It doesn't have anything to do with the values in the distribution. It's about the numbers in the distribution, number of items in it. The first point is termed as the first quartile, the second quartile, then you have third quartile. The location of the ith quartile indicates always 4, right? 1 over 4 can be calculated as this. Now, 12 students in a class have the following weights. What are the quartiles? Where the quartiles are separated. Let's look at them. Now, what should we do first? Can somebody tell me what should we do first with this? First thing. What is the first thing that you should do? Arrange the values in ascending order. Very good. You need to first ascend the numbers in the increasing order. So you have to find the smallest value and you make it the first one. So 47 is the smallest one as I see. Make it 47. And then you have 48. Then you have 56. Then 59. Then you have 65. 67. 68. Then 77. 79. And 81. 83 and 92. Make sure that you put everything in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 students. In class have the following weights. What are the quartiles? Now, Q1, it's going to be, Q1 is going to be 1 over 4, 12 plus 1 item. That's going to be 13 divided by 4. 13 divided by 4 is going to be 3.25. 3.25. So 1, 2, 3. Just put a line there, just in case. And then you have Q2. That's going to be 2 over 4. 12 plus 2. That's going to be 14 divided by 2. That's going to be 7. 1, 2, 3, 4, 5, 6, 7. And then Q3 is going to be 12 plus 3. 15 divided by 4. That's 45 divided by 4, 1.25. So 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. That's going to be the Q2 and Q1. For the Q1, now this is the item. This item, right? So In both cases, you have 0.25, and I think this should be 45 divided by 4. That's 1.25. Yes. So this 0.25, how do we get this value? It's the item. It doesn't have a particular value in the distribution. So here you have 68 years, but in the case of 11.25, do we have 11.25 value? It's 83, but in fact, it's actually, it's not 83 because this is 7, 8, 9, 10, 11, 11.25. This is the actual value. So how do we get it? For 68, we have, yes, that's the Q2. 68, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. So 7 actually is the median. This is actually the median. Q2 is the median. Now, how do we get Q1 and Q3? To get this one, you need to get the first value in front of Q1 and the second value after Q1, that is 56 and 59, and assume that the distribution has a linear trend, which is if you order them, then from 56 to 59, it goes in a linear trend. So if you, now you have organized this one according to the ascending order, right? So let's say 1, 2, 3, and all the way. And if you order them, so you have 47, 48, 56, and 59. So we assume that these values follow a linear trend. There can be other assumptions as well. That's what I'm bit specific about this. You can fit this to a distribution and then find this 0.25 value depending on the distribution. But it's gonna be it's gonna require effort. So if you are going with the linear trend, then you can take, all right, so I have 56 here, then I have 59 here. What will be the 1/4 of that? That is 0.25 of it. Then take that value. That's the way to do it. So 59 minus 56, that's 3. And so 0.25 of that is 0.75. So Q1 is going to be 56.75, right? Because that is going to be 56. This is going to be 56 plus 59 minus 56 times 0.25. So that's going to be 75, right? So that's 56.75. The same goes here as well. But now it's 83 plus 92 minus 83 times 0.25. So 92 minus 83, it's going to be 11. Sorry, 9. 9 times 0.25 is going to be somewhere around 250 minus 25, that's 225. That is going to be 2.25. That's going to be 85.25. So Q3 is going to be 85.25. So that's the difference. Okay. Now that's about quartiles. The interesting thing about quartiles is when you divide the distribution into Q1, Q2, Q3, it separates the distribution into four places. So you have this one, and you have this one, and this one. So Q3 minus Q1 is known as the interquartile range. We'll use it because Q3 minus Q1 is used in other like anomaly detection and all these things. So Q3 minus Q1 is known as the interquartile range, Q3 minus Q1. IQR, interquartile range. Right. Now let's go to the next one. The advantages and disadvantages of mean, median, and mode. Measure is the mean. Advantage, used with interval data, useful statistical properties, easy to understand. Disadvantages, affected by extreme values. Think about how extreme values would affect mean, because these kind of questions are there in the exam paper, and also some interesting thoughts. May not appear in data. Yes, mean will not appear in data. Need interval scale data, need symmetric data. If it is not symmetric, the mean doesn't actually tell anything. If you have group data, some data points here and some data points here, then the mean actually doesn't mean much, because this point is far away from the mean. This one is also far away from the mean. Now, again, measure is median and mode. If you are looking at the advantages, it can be used with ordinal data. Ordinal data in the sense you have some ranking system. Then unaffected by extreme values, median is inside the value. So easy to calculate, symmetric data not required. This restricted statistical uses may not appear in data. Again, mode used with nominal data, can use it with nominal data because it's a frequency, right? Appearance again and again, you can use it with nominal data. Easy to calculate, again, restricted statistical use and limited use. We'll come to group data distributions with the group frequency charts and all those things in the next lecture. And I hope by that time I can ask to conduct some tutorials on this particular area, all the way up to covering the descriptive statistics parts about the central tendency and the summary. Then we'll go to group data distribution, measures of dispersion quickly. Then we'll talk about inferential statistics afterwards.